Hello, Mr. Eric, are you right?
Yes.
Okay, so how do you I give you a sequence, okay, like 1, 3, 5, 7, 9. Do you notice what's so special about this sequence?
They're all odd.
All numbers, okay? And how about, look, if it is 1, 5, 7. This is not special, but this one is special. Why is that?
Because they're all odd numbers.
These are all numbers, but what's so special about this one?
That I think it's
Huh? How do you write this one? What's that?
don't know. Wait, what? They're all adding 2.
Adding 2, okay. So the distance between each number is 2, right? It's the same, okay?
Yeah.
So like 1, 2, 3, 4, 5. This is also like, how do you call it, what, to spell it what? A-R-I-T-H-M-E-T-I-C. Sequence, okay. So we call...
Permutation.
Yeah, sequence. We call this arithmetic sequence. So each number, the distance between each number is the same. But what do we mean the distance is the next number minus the previous number. Okay, so how about this? 1, 5, 1, 5, 1. Right, the distance is also 4, but look, 5 minus 1 is 4. 1 minus 5 is minus 4 and 4. So this is not, right? This is not, right? So we are looking for the numbers that the first number is A.
I know.
Yeah?
I know.
The second number is A plus D. The third number is A plus 2 times D. And the next number is what? A plus 3 times D, etc. Okay? Right? A. So the whole sequence, you can put it as A plus K times D. Okay, so for given this so can you tell me, alright? Can you tell me what's A and D in for this 1, 3, 5, 7, 9, 11, etc. What's A?
2.
Sorry, what's A? The A is the first number. Which one?
1.
1. Okay, and what's K? What's K is the number. Okay, what's D? What's D? D is the distance. What's D?
2.
2. Okay, so look, this sequence we can write it as what? 1 plus 2 times K. 1 K equals 0 is 1. K equals 1 is 3. K equals 2 is 5. K equals 3 equals 7. Okay? Yeah? Okay, so now we know this sequence. Oh, so I give you a few numbers, like, but they are not essentially in order. So for example, 7, 3, 1, 5. So can you tell me how can you rearrange these numbers to make it a arithmetic sequence? So you become what? So can you do
1, 3, 5, 7, easy.
1, 3, 5, 7. Okay. Okay, easy. Okay, so given a list of these numbers, not essentially in order, can you tell me if you can rearrange the sequence to make it an arithmetic sequence? So what's your thoughts? How do we do it?
I'm not sure how to explain.
How do we do it? How do you know it's one? Okay, from these 3, 7, 1, 5. How do you know it's one? Or you can do it 1, 3, 5, 7. Come on, it's very obvious. How do you do it?
Brute-forcing.
How do you brute forcing? Come on, how do we do it?
You definitely start with the smallest to biggest.
Yeah, small is biggest, and how do we got it? How do we check? We can what? We can what?
We can check.
How can we check? How can we do
We
it?
go to the second number and then use our previous one.
Okay, so before we do that, we want to what? We want to what the numbers. Come on, we want to what? We want to put in a verb here. The numbers. Can you imagine how do we do it?
Sort.
Yeah, that's the what I'm looking for. Sort. Yeah, we sort it. So what's the sorting time complexity? If there are a number, what's the time complexity if we sort the numbers?
And again.
Yeah, okay, we're done. Okay, so We only saw the numbers. And if we saw the numbers, how do we check if it's an arithmetic sequence?
If we go to the second number and then we
Minus, subtract the previous one, yeah? And then we check if it's
like you did.
and the distance that needs to be the same, right?
Yeah.
And how do we check if the distance is the same? We can put the distance in a set, and then we can finally count the number of the distance, unique distance in the set. It has to be 1, right? Right? Yeah, we can use the set. Yeah, notebook. Okay. Okay. So let's say define is a arithmetic sequence. Okay. And numbers. First of all, we only sort. Yeah, nums dot sort, right? Okay, then we put a distance in a set, yeah, d equals set. Okay, set is a hash book, contains only unique number. Okay, and then how do we solve this? For I in range, we start with the second number, so what should we put here? We start with the second number, so what should we range? It will be
1.
1, and then to the length of the numbers. Okay, then the distance is what? We want to put this distance, d dot add. What's the distance we want to put? Alright? D dot add what?
D dot add
What?
the
Nums what? I minus what?
the previous one.
Nums what?
I 0.
Minus 1.
I minus 1.
Okay, now look, we can put here, if length d already bigger than 1, we return what? What does this mean? If this set contains 2 different distance, then we know it's not arithmetic sequence, right?
Mm-hmm.
And so we return what? We don't know what?
Both.
Okay. And then here we can just return, because we already checked here, so we can return what?
Return true.
Okay, then if I remove this one, so what should I rewrite here? Return what? If I don't.
Then if d equals 0, no 1. D.
Length d, right? The number of the unique distance is equals 1. Okay. Do we actually need to put a set?
No.
No. Okay. If I tell you I don't want this, I don't want this, I don't want this. Return this will return true, right? So if what? Nums I minus nums I minus 1 not equal what? Can you tell me? Nums what? Minus nums what?
What?
Return, you put the 2 numbers here. Return false, right? Right? Look at it. 1, 3, 5, 7. We start from this one. Yeah? I is here. I minus the previous one, not equals 1. I minus this, not equals 1. Come on. If the distance, we can get the distance from which number? Which 2 numbers?
The first one and the second one.
Okay, so the first one and second one, how to put this? Nums what?
1.
1, nums what?
0.
Well done, that's it. Yeah, does it make sense? Yeah? Got it?
Yeah.
What's the time complexity? Sorry? This bit is what? This bit is, what's the time complexity of this bit?
N.
And what's the time complexity of this bit?
N again.
Okay, so what's the final complexity of this whole?
N again.
Yeah, because this is dominating, yeah. This is bigger than that. You can say all n log n plus n, right? But this is constant. I mean, this is adding together, but so this one dominating. So you can drop this. This one is dominating because it takes more time, right? Time complexity, okay. Okay. Okay, I'm gonna erase this bit, okay, and then you tell me or return. You can write one of these. Come on. That's it for today. Come on. Come on. Yeah. I write a few one. You can remember the notebook or you can do it without the notebook. Okay. Anyway, think about it. How do we check if the number we already sorted and how we are going to check? Yeah. You still remember if what? Yeah. Come on, Eric. It's show time. Okay. Eric, it's your time.
And I
Sorry?
I don't know.
You don't know what? If what? If what? What are we doing here? Oh, you can put it in a D, in a hash set, remember?
I don't want to create a hash that.
Sorry?
I don't want to create a hash.
You don't want to have, okay, then if nums I minus nums I minus 1 not equals what? Come on.
I'm pretty sure it's 1.
Okay, yeah, come on, write it.
I'm pretty sure it's 1
Yeah,
minus.
yeah. Nums 1 minus nums, yeah.
It's not not equals.
Uh-huh. And then what?
And don't know.
If nums 1, and then we are iterating with the I, right? So the I and the elements at I and then minus subtract the I minus 1, right? If we know equals num.
Nums 1 minus nums 0.
Nums 1 minus nums 0 is the first distance, but we want to make sure that the rest are the same. The distance I. Look, I start from a second number, right? So num if not equals nums I minus nums I minus 1. Remember?
Nums I.
Yeah.
And
Minus. Yeah. Remember nums I minus nums I minus 1. Yeah. Yeah, and then we found a difference in the distance. So what should we do? Return what? Return what? Yeah, return true if we don't find any violations. And here is if we find a like violation, we return what? That's it. Great job today. Good job. Bye bye.